The problem with this problem is it's not in user-friendly format. In other words, I can't just look at it and quickly identify the center or A, B for the major and minor vertices, etc. So just like before, if it's in standard form, I gotta get it into user-friendly form using completing the square. So I'm gonna factor out anything touching x squared and y squared. So for this part, I'm gonna factor out the 25, so that leaves me with x squared minus 2x, leave a little bit of space. Same thing for the y. I'm going to factor out the 9, so that's going to give me 9 times y squared minus 8y, leave a little bit of space. And anything that doesn't have an x or a y, like this one here, I'm going to bump to the other side, so that equals 56. Now this is basic algebra 1 in terms of the skill set for completing the square. I take half of the middle squared, so half of that is -1 squared is 1. Do the same thing for the y parentheses. Half of that is -4 squared is 16. So again, anytime I add or subtract anything from one side of the equation, I have to do it to both sides. So did I add 1 and 16 to both sides? And the answer is no. You have to respect these parentheses. I didn't just add 1. I actually added 25 times 1, which is 25. Same thing for the y's. I didn't just add 16. It was actually 9 times 16 when I introduce that 16, so that's actually 144. Okay, now I'm gonna get it into a slightly cleaner format using just factoring. So this is gonna be 25. This should be super duper easy to factor. X minus 1 quantity squared plus 9 y minus 4 quantity squared equals, if I add all of those up, that equals 225. Okay, so here's the deal. We're almost done. Now, the right-hand side should not equal 225. For my equation, it should always equal 1. So what I need to do is I need to take this number and turn it into 1. How do I do that? Divide all three of these fractions by 225. If I did that, okay, that's going to equal 1. So we still have these two fractions here. I'm going to have y minus 4 quantity squared, x minus 1 quantity squared. Now, if I have a 225 down here and a 25 up here, if I reduce, I'm going to be left with 9. And if I have a 9 on the top and a 225 on the bottom, if I reduce, it'll be a 25 on the bottom. So there's my equation. I actually prefer to write this as 3 squared and this as 5 squared, just to make it a little bit more foolproof. But now that I have my equation, I should know which way this ellipse is oriented and be able to figure out all these components, okay? So I should be able to recognize that this is a tall, skinny ellipse just because the bigger number is underneath y, okay? Before I do that, let's nail the center, the easiest points, and the most important points, because if this is wrong, obviously everything else is wrong, okay? Now it becomes exactly like what I did before. The major vertex is going to be given by A, which is 5. The minor vertex or vertices is B, which is 3. And how the heck do I find C? It's the anti-Pythagorean theorem. So I'm going to do A squared minus B squared. So C is the square root of that, which is 4. Once I have that, I'm going to use a little bit of geometry logic to figure out the location of my major, minor, and foci. Okay. So once again, if I have a tall and skinny ellipse, that means my major vertices are above and below. Okay, which means I'm going to change y, but I'm going to keep x, which means this x is going to be the same as this x as this x. Okay, so how do I change y? Well, again, if I want to move up, I'm going to add to the y coordinate this specific value. If I want to move down to find this one, I'm going to subtract that specific value from that same exact y. So that's going to give me -1. Okay, do the same thing for the minor and the foci. We have the values, we have the center, so we can logically figure out what those numbers are. Minor vertices are left and right, which means the x's will change, so I keep the same exact y as the center. Okay, how much do I move right and left? 3 spaces. So 1 plus 3 gives me 4. That's how I move to the right. And 1 minus 3, that is -2. That's how I move to the left. Okay. Foci is lined up with the major vertices, so it's going to behave very similar to what I did here. So my x's will stay the same. my y's to move up and down, add 4, subtract 4, and I have all the coordinates I need.